is younger, but other than that, Oriental is pretty young as far as Mare go.
Kelsey, thanks for that. We love later volcanism too. How about when the actual crater was formed?
Yeah, we're going to get you an age for Oriental, and while we're getting that, Christina, can you, maybe you've heard the window team talk about the sort of contacts around Oriental, but because that material is so much younger, if anything pops out to you about physical relationship between that and surrounding terrain, we'd love to hear it.
Yeah, definitely. They are discussing a contact relationship that could explain some of the color that they're seeing in certain areas. And so it was really about the ejecta of the creation of the basin and understanding the superposition of its ejecta and Mare on the near side or other features. So thank you. We'll take the insight when you have it.
Thank you, Integrity. And I know Jenny wants to get to you with some topics, so I'll leave you with Oriental is 3.8 billion years old.
Copy that. So that's on the older side. The actual basin is very old.
Correct, as is the case with a lot of Mare. Typically the big basin formed, and then the volcanic eruption was able to punch through the crust where it was weakened by that basin formation.
Perfect. Tracking. Thank you.
NASA astronaut Christina Cook calling down some questions to the science team on console. The voice you're hearing with those answers is Dr. Kelsey Young. She is joined by Trevor Graff on console today. Christina asking about the age of Oriental, and specifically the Mare regions. Those are those dark regions that you see. They are paved or filled by volcanic deposits.
Integrity, it's about time for a position swap at the window, so we will ask Reed and Jeremy to swap positions, and I'll remind you again about your SD cards. And Victor or Christina, I have one window task for the cabin team when you're ready.
They are swapping and I'm ready.
All right, Tina, we found a way that we can reinstall the shroud on the window. We understand it's pretty darn bright compared to everything that you're looking at. So in order to reinstall it, we will ask that you retrieve the condensation hose and you install it on a friction fit on the cabin air outlet port. That's right by one of your diffusers You're going to point that little condensation hose such that the air is flowing over the window pane. Let me know when you're ready for the stowage location.
Ready.
Christina, the hose is in locker A1.
The crew has gotten a go to reinstall that window shroud they were using to block some of the earth shine.
Copy.
This view coming from inside the Orion spacecraft as the crew members are swapping windows, specifically Reed Wiseman and Jeremy Hansen. They've been our crew members at the windows taking photos, making annotations, and making recordings that'll be downlinked later to the science team for review. The science team will have a conference tomorrow morning with the crew to get any fresh perspectives or things that they learned during the flyby. Again, we are now in the third of 5 observation blocks for the crew scheduled for today. During this flyby, Orion is passing around between 4,000 and 6,000 miles from the moon and providing the crew with a full view of the lunar surface. It's a higher vantage point and much farther than Apollo's lunar orbits on average. So from this view, astronauts can observe both the North and South Pole and large-scale geologic features in one single view. We are now just under an hour until Orion passes behind the moon, and we lose communication with the crew. They will be out of reach with any of our deep space network antennas.
Awesome, that means it'll be 6:44. That means at 7. Mom, you'll be able to be
communications with them once they fly behind
Mom, you'll
the
be
other
able to
side
watch
of
it
the
with
moon.
me.